Achha, so what's the definition of a mole if they're going to ask you about moles? Yeah, what will you write? Like what's a mole? I mean, the multiple definitions acceptable, like any one of them. Okay, anyone? Ahmed? Basically, just make a rough guess. South the idea. What is it? So if they're going to ask you the multiple definition, it's the number of particles. So you know how many particles a million will have, how many particles a dozen will have. You can count anything using moles. So it's the number of particles. Uh, it's the number of particles equal to the Avogadro's number. And what's the Avogadro's number? That's 6.02 times 10 to the power 23, which is a big number. It's a much bigger number because you've got too many atoms. That it's a lot bigger than a billion or a trillion or a million. It's got 23 zeros in it. So it's the number of particles equal to the Avogadro's number, which is 6.02 times 10 to the power 23. So if I say I've got one mole of things, that's I've got these many things. They could be sodium atoms. They could be, I can be counting stars with it. So I can pretty much count anything using moles, but usually it's just atoms and molecules that are counted. Because even stars are counted up till billions. I mean, we've got 400 billion or so stars. So you don't, only atoms are so many in the universe that they need a much bigger unit for counting. The other thing is, how do you convert that? I'm going to go over some of the formulas. So the first conversion is, how do you convert to moles? That's number of particles, and that's going to be divided by the Avogadro's number, which is 6.02 times 10 to the power 23. That's your first formula. And this formula is equivalent to conversion into any unit. Like if I have 72, I want to convert it into dozens. So what do? I divide it by 1 dozen, which is 12. So I've got 6 dozens. So if I want to convert any number into any particular unit, I just divide it by the unit. So if I want to convert, let's say this number into thousands, how many thousands is this? All I need to do is I need to divide this by 1,000. So I'm going to get 500, and that would mean that I've got this would be 500 actually. So that would mean I've got 500 thousands. So conversion into any unit is just divide by that particular unit, and that's your first formula. And any number can be converted into moles using this way. We'll be counting atoms in moles. Either we've got 1 mole of certain substance, or we've got 2 moles or 3 moles. That's our first formula. The second formula is that moles, you can convert it into mass. How do you do that? That's moles is equal to mass divided by the MR or AR of a particular substance. Assuming that it's a pure substance. AR is the relative atomic mass and MR is the molecular mass. Now this formula is exactly the same as I mean, if you know the quantity, you can convert it into mass. How can you do that? Like if I know that one apple has has a mass of 200 grams. So 10 apples would obviously be the mass of one apple multiplied by 10. That's going to be 2000 grams. So it's basically the molecular mass, which is the mass of one molecule, or the mass of 1 mole of a molecule, that's known as the molar mass, into the number of moles. So you just have to multiply the two together. That if you know the mass of 1 mole, so this MR or AR is the relative of molecular mass, and there's a thing called the molar mass. So what is the molar mass? Molar mass is the mass of 1 mole of a particular substance. So it's the mass of 1 mole of a substance, and it is basically the AR or MR expressed in grams. Okay, are you guys already familiar with all of these, right?
Yes.
Okay. What are the formula? There's a formula for solutions. Now, for solutions, you've got a term concentration, which is that a solution could be concentrated. And remember, the term concentration is only for gases and solutions. So concentration refers to the fact how far or how close together are the particles. So the spacing of the particles can only change in either a solution. Like if you have a certain particle dissolved in water or a solvent, then the particles could be very far apart, or they could be very, very close together, right? So if they're very close together, then that's concentrated. If they're very far apart, then they are dilute. So this is concentrated, and the other one would be dilute. So this one over here, I'm going to make it dilute. The particles would be far away from each other. There would be fewer particles. So what is concentration? This could apply to gases as well. Remember, in solids, the spacing, the term concentration does not apply because the spacing does not change in a solid. In solid, the particles are always tightly packed. The same goes for liquids as well. The spacing, like if I've got liquid water, the term concentration does not apply because in liquids, the particles are all close to each other. Only in solutions and gases. Now, what is concentration? It's the number of particles per unit volume. So so the formula of concentration is it's the number of particles in a particular volume, and the volume is going to be in dm cube, and the number of particles are counted in moles. So it's mole per dm cube. That's what concentration is. And you can rearrange concentration. N is usually the unit for, it's usually the symbol for moles. So if I rearrange this, it's going to be N is equal to C into V, which is concentration times volume. So all solutions are going to be described by their concentration, whether they're less concentrated or whether they are more concentrated. So this is mole per dm cube. This one is dm cube. Is that clear?
Yes, sir.
Yes.
I'll just hold on one second.
Yes.
You just give me 1 second. So that's going to be used for solutions, and then you have one for gases. There's a fourth formula which is for gases. All gases at RTP would occupy what volume? It's going to be, so 1 mole of any gas occupies 24 dm cube at RTP, but remember it's at RTP only. At room temperature and pressure, it's going to occupy 24 decimeter cube. And so based on that, 2 moles of gas would occupy twice the volume. That's going to be 48 dm cube, and you can convert that into a formula as well. So moles would be the volume of gas, and remember this is for gases only. And you're going to divide by the molar volume, which is 24 dm cube. So that's going to be our fourth formula, and I'm going to talk about these main formulas first, and we'll do the other formulas much later on. So just remember this last one, that's only for gases, and just make sure that you know how to do the conversions. Okay? If you have a calculator with you, make sure you keep a calculator with you. So we'll do a few questions, a bunch of questions. Let's say I've got the question is I've got 20 grams of aluminium sulfate. So how many moles is this? Can anyone try and calculate this? I mean, that's question number one. What do we have? Moles is equal to mass divided by the molar mass, which is going to be aluminium is 27 times 2 and plus the 3 SO4s. So that's 3 multiplied by SO4 is S is 32 plus 16 times 3 and the 3 SO4. So that's so try and calculate what the moles are for this one. Sorry, try. What's the answer to this one? And I'm going to open the
0.07.
So you're getting 0 point? You can tell me exactly.
0.7.
So let's say I make this 20.0 grams for a second, just a second.
So I'm getting 0.058.
0.058?
Yes.
Are there any numbers after that?
Yes, sir.
What's coming after that?
4795.
4, 7. So I'm going to make it 5, right? Anyways, there are 2 questions there now. There's nothing wrong with the calculation. It's simple calculation, but now you have to be very careful about 2 things, and I'll just explain those 2 things. And I'll explain those 2 things very quickly. First thing, accuracy. Make sure you take the appropriate accuracy. Like for example, always try to, I don't know if I've opened the, you've got a data booklet now, although that's no longer with you, but it will be printed in the paper. But you can download, you can just put 9701 data booklet in Google and you'll find a data booklet. But it's no longer as a separate component. It's mostly printed with the question paper or in between the question paper since 2022 now. Anyways, first thing, make sure, like everyone knows that carbon is 12, but make sure you take the exact accurate value. For example, sulfur, if you do it by memory, is 32, but it's actually the real value is actually 32.1. So make sure don't make the mistake in your paper by taking inaccurate values. So for example, there's an error over here. This should not have been 32. This had to be more accurate. It had to be 32.1. The other ones we can just double check is aluminium 27 or not. We can just have a look at the pure table. That's 27.0, so it's pretty much the same thing. So that won't mess up our results. But one of the values was not appropriately accurate. Can you redo the calculation and tell me the exact answer now? Because our answer at the moment is slightly inaccurate. Has anyone done redone this calculation using 32.1?
Sir?
Yeah.
So I did like 16 into 12 here for this one.
Sorry, this is 16 into 12, yes. Okay, Saad, your answer was correct. I made the mistake. It is 16 into 12, yeah.
Like, it should be like this, right?
Hey, sorry, no, just a second. I think I multiplied 16 by 4, right? I mean, what was over here? It was, yeah, I did it right, actually. I did 16 into 4. Okay, just a second. It's